You've all heard that flying is the safest way to travel, and statistically it is. Even as our world's airspace becomes more crowded, flying today is actually becoming safer. But unfortunately, fatal aircraft accidents can still occur. That's why researchers in the Aviation Safety Program are working on revolutionary technologies that may make fatal aircraft accidents a thing of the past. The Single Aircraft Accident Prevention Project, or SAP, is part of the Aviation Safety Program that is developing new technologies that may help pilots recover and safely land an aircraft from a potentially fatal event. I spoke with John Foster in the Vehicle Dynamics branch at NASA Langley to find out more about SAP.
Well, the SAP project is developing systems that will anticipate failures on the airplane before they occur and help the pilot recover the airplane if an out-of-control event should occur.
What's an example of an out-of-control flight situation?
Well, there are a number of factors that can contribute to an airplane loss-of-control accident. These factors can be both internal or external to the airplane. Some external factors may include severe weather or just poor visibility. Some internal factors, though, could include some failure in the control system, as well as a structural failure or just an inappropriate crew input.
In many of these situations, catastrophic failures cause the pilots to lose control of the airplane, resulting in a fatal accident. Researchers in the SAP project are working on new technologies which they hope will prevent these types of accidents from ever occurring again. They are developing a series of revolutionary systems that will not only detect and predict system or component failures before they become severe, but are also developing automatic control recovery systems, which will actually help pilots recover an airplane from an upset situation. Okay, so how do these systems help a pilot out? I mean, how do they work?
Well, the Vehicle Health Management System is being developed, which will continuously monitor the airplane's health and compare that to the math model for a healthy airplane. In case a disturbing trend or an anomaly occurs, it can send that information to the ground crews and they can take the appropriate maintenance action to fix the part after the airplane lands.
Wow, kind of like an onboard doctor.
Exactly, that's why it's called health monitoring. Another system being developed as part of the SAP project is the control recovery system. This system is being designed to help the pilot in case the airplane gets into a loss of control situation. That system will carry a math model of a normal maneuvering airplane on board. And if the system detects that the airplane is about to enter a loss of control situation, it can alert the pilot and help him to recover the airplane, or it can automatically recover the airplane for the pilot.
These systems will not only be able to help a pilot regain control of an aircraft quickly, but will also be able to help land an aircraft that has suffered catastrophic damage. With these new systems on board commercial planes, pilots will be able to maintain safe flight even under the most adverse flight conditions, potentially making fatal crashes a thing of the past. Okay, so the systems you've mentioned are obviously computer systems, but we're standing here in a wind tunnel. How does wind tunnel testing help?
Well, wind tunnels are used to develop pilot training simulators. We can take the data out of the wind tunnel for extreme flight conditions and put that in the simulator and allow the pilot to experience an out-of-control event and conduct training to learn how to recover from such a situation. Our goal is to provide the most realistic training possible for the pilots in case they would enter a loss of control situation.
John, how will these systems be tested before being implemented on an airplane?
Well, there are several methods that we can use to test the systems before they are actually implemented in the airplane. One is to use a subscale, dynamically scaled flying model of the airplane. In that model, which is remotely controlled, we can install the actual systems in onboard computers and then fly the model through various out-of-control flight conditions and then see how the system works to recover the airplane.
What are your hopes for the future of this project? I mean, what are the future goals of SAP?
Well, flying is already a very safe form of transportation, but accidents still occur. And our goal in this research is to develop systems that will specifically help reduce those kind of accidents and save lives.